Hi again, everybody. Welcome back to MTED110. This is lecture 2B. We're going to be doing 2B. Now, you should have already completed activity 3A at this point. So let me go ahead and pull the slides up. There we go. Remember, this is where things are kind of shifted around. So you should have done 2A and then 3A. Now we're going to do 2B, and then you'll do 3B. So the reason for that is that chapter 2 was all about our numeration system, and then chapter 3 is all about operations, operating on these numbers, right? So what was cool is in the videos we watched at the end of the last lecture, you could see how place value was so important to being able to do those operations. And now we're going to see how that still holds even in a different base. So let's get right to it. Yeah, so you notice that the concepts of addition and subtraction and the models are independent of any numeration system. Remember, what is addition? It's bringing things together. What is subtraction? Taking things out, right? That's the idea. It doesn't matter what numeration system you're in, you can still do those operations. That kind of emphasizes the point that it's just a representation, right? It's not the actual thing. It's not the numbers, it's the numeration system. There you go. We spoke only of numbers and quantities. We weren't talking about numerals when we were talking about addition and subtraction. Those are not things that you do to numerals, they're things that you do to numbers. So that means that you can perform those operations in any syntax of any numeration system. Okay, in other words, we can add or subtract and divide in any base we want, or any, even if it's not a basimal system, right? Like not everything is a basimal system where you have a certain base or place values, that kind of thing. Addition and subtraction are prevalent, and multiplication and division. You don't have to have a numeration system to do them per se. All right, so this is actually pretty quick. We're just going to do a few examples right here. I'm going to make some up off the top of my head. How about this? How about we do 1, 3, 2, 3 in base 4, and to that, we're going to add 1, 2, 2, 1. Let's try that, base 4. Okay, so the thing to keep in mind is that I have no idea what quantity this is because I'm more of a base 10 guy myself, right? All I know is that there's a quantity represented there. And I don't need to convert it to base 10 to make sense of this operation. I just have to remember that this is a base 4 place value system and that each one of these numerals is in a certain place, and each one of those numerals is telling me how many of a certain power of 4 that I have. More specifically, actually, let me give myself some space. More specifically, oh, there we go. Huh, nice. This is the 4 to the 0 place, right? That's the 1's place. That's the 4's place. That's the 16's place. And there's the 64's place. That's actually 64, 4 cubed. And that's it. So I'm just going to go through and add those up and then kind of convert as I go along. So let's see how we begin. All right, first, here we're doing 3 plus 1. 3 plus 1 is 4. So how do you write 4 in base 4? Well, you've got one group of 4 and 0 left over. So let me go ahead and use this purple. 0, 1. There we go. Now, let's do this next operation. Here, we're going to be adding 2 plus 2 plus 1. That's 5, right? There's 5 objects there. How do you write 5 in base 4? 1, 1. There we go. Now let's do it again. Let's go on to the next column. So now we're going to do 3 plus 2 plus 1. 3 plus 2 is 5, plus 1, that's 6. How do you write 6 in base 4? 1, 2. One group of 4 and 2 left over. So we're going to have one group of 4 and 2 left over. And then last but not least, there's 3 right there. And that's our final answer. 3, 2, 1, 0 in base 4. Again, I don't know exactly what quantity that is because I was born and raised base 10, but I was able to do that addition without having to convert it. And I just want to emphasize that right here. Do not just convert to base 10. Yeah, so what I don't want you to do is I don't want you to convert both numbers to base 10, add them together, and then convert them back to base 4. No, that's not what you want to do, because if you're doing that, then you really don't understand numeration systems that well. And that's a key skill that you need as a teacher, and frankly, as a human being, I would say, being able to understand numeration systems. So make sure that you don't just convert to base 10. Okay, Let's do another one. Let's do one that's in let's do base 12. Let's do base 12. So remember with base 12, we need new symbols for the numbers 10 and 11. So we'll use A. A is going to be 10 in base 10, and B is going to be 11 in base 10. And how about we add up 1, A, B, 9 plus A, B, A, B, base 12. Why not? Why not? And this is what's great. You can make up all sorts of these problems. You can make up as many of these problems as you want and just try them out. And there's plenty of like online calculators if you want to check your work. But better yet, just have one of your group members check your work, because that's exactly what you'll have to do as a math teacher. Exactly what you'll have to do. So this is the perfect time for you to get some like hands-on real experience with doing this type of stuff. All right. Let's go ahead and calculate. What are we doing first here? First thing we're going to do is we're going to add 9 and B. But what's B? B is 11. So we're doing 9 plus 11, which is 20. What is 20 written in base 12? 20 in base 12. Base 12 is one group of 12 and then 8 left over. So we're going to have one group of 12 and 8 left over. Right, now we're going to do B plus A plus B. B is 11, A is 10, so we're doing 1 plus 11 plus 10. That's 22. So how do you write 22 in base 12? Well, 22 in base 12 is going to be one group of 12 and then 10 left over. One group of 12 and then 10 left over, but that's an A. So we're going to have 1A. All right, and actually we're going to end up with the same thing here, because we're going to have, right here, we're going to have A plus B plus 1 again, which is A. All right, next, we're going to have 1 plus A, which is 10 plus 1, which is 11, so it's B. And there it is. There's the answer. BAA8, base 12. And that's how you do it. Easy peasy, right? Maybe not so easy. It's funny how some things can seem simple, but that doesn't mean they're easy. You know what I mean? This stuff makes more sense the more you do it. And the more you do it, the more our own numeration system is going to make sense to you. It's really, really cool. Okay. Now, how about we do some subtraction? Let's do some subtraction. Okay, let's go ahead and do this. And let's do base, we did 4, we did 12. Let's do base 8. How about that? And let's do 6, 4, 1, 3, base 8. And let's take away 4, 2, 1, 2. Actually, that's too easy. That's too easy. Let's do 4, 5, 2, 1. There we go. Okay, so again, the key idea here is that this is just some quantity represented in base 8. We're starting with this number, and we're going to take away this number. That's what we're doing, right? So the thing to keep in mind is follow what those kids were saying in the videos, right? It doesn't matter exactly how you write things as long as you're keeping track of what quantities you're dealing with. And so what you'll see is when I write numbers up here, when I write numbers above those numbers, I'm not always going to convert them into base 8 because I'm really just trying to tally how many things I have. You'll see what I mean as we go along. All right, let's begin. First, we're going to do 3 minus 1, which is just 2. Oops. Which is just 2. Now, the next thing we want to do is 1 minus 2, but we don't have enough things to take 2 away. So what we have to do is we have to go over here and we have to take one of those powers of 4, or powers of 8, sorry. Remember, these are just counting how many 8s we have. Well, this is the 8s place, or sorry, actually, let me do this before I get too carried away. Emphasize this. Remember, these are the 8 to the zeros. Those are the 8s. These are the 8 squareds, which is 64. And these are the 8 cubes. 8 cubes. No, I forget what 8 cubed is. We'll have to calculate it in a second here. So that's the thing I'm trying to keep in mind here. All right, so when I go over here, and I break this apart, there's only going to be 3 there, but that's an 8 squared. So I've got 64 things, right? 8 squared, 64 things. But how many eights is 64? 8 times 8 is 64, right? So I got 8 eights. And then to that, I'm going to add the 1 8 that I already had. So now I've got 9 of those eights. 9 of those eights. And now I'm taking away 2 to make it 7. That's the idea. Keep in mind what these numbers are representing. They're representing how many of that group you have. Okay, so now let's go to the next part here. We've got 3 objects, and we're trying to take away 5, so we don't have enough. All right, let's try this out. We're going to go over here. Now what we're doing is we're getting 8 more things. We're getting 8 squareds, right? Remember, 8 cubed is the same thing as 8 squared times 8. So we're getting 8 squareds when we break apart one of those 8 cubes. So now instead of only having 3 8 squareds, now we're going to have 11 of them. 8 plus 3, right? So 11 minus 5, now I'm doing this, 11 minus 5 is what? 6. And then last but not least, oops, that's an 11, come back. We're going to do 5 minus 4, which is 1. And that's the answer, 1672 base 8. So that's really what it is. It seems a little bit complicated, but you just have to keep in mind that these numbers up here are keeping track of collections. You just have to see how many you've got. Okay, let's do one more example. One more example. Yeah, good timing. One more example. Let's see, what's a good base? What's a good base? How about base 5? Why not? Let's do base 5. And in base 5, we're going to have, how about, now I want a pretty big number in the front. 4, 2, 1, 3, 1, 3, 2. Yeah, why not? And then let's take away 3, 1. Actually, no, I don't want to do I don't want that to be negative. Let's do 1, 1, 2, 3, 2, 1. That'll work. And these are all in base 5. And remember, there's an emotional component to that. Don't let that freak you out. Those are just some numerals representing some number, right? The process is the same. It doesn't matter how many that there are. We're just going to go through it systematically. I don't expect you to be able to look at this and just suddenly know the answer. We're just going to walk through very slowly and methodically. Here we go. First, the easy part. 2 minus 1 is 1. So we get that for free. 3 minus 2 is 1. 1 minus 3, this is the first time where there's a little bit of a dilemma. We've got to go over into the next column, and we've got to bust up one of those so that we can put it over here. So now, this is only going to be 2, but we're going to get how much? We're going to get 5 objects from that. We're going to get 5 groups of 5 squared. We've already got 1 group of 5 squared. So now we have 6 groups of 5 squared. We took 5 from over here. All right, so now 6 minus 3 is 3. 2 minus 2 is 0. 1 minus 1 is 0. 2 minus 1 is 1. And then 4, and that's it. That is it. That's the idea. A lot of students get really confused with this particular part of it. This is the part that you have to pay the closest attention to. And if it really gets to you, try to do the same thing in base 10. And what you'll realize is that you keep borrowing these 10s, right? You keep borrowing these 10s, but borrowing doesn't really make sense. We'll talk about that in the next lecture, actually. I think it's the next lecture. Pretty sure it's the next lecture. Borrowing doesn't really make sense, but you got to keep in mind what you're taking. We're not taking tens anymore, or hundreds, or thousands. We're taking powers of 4, or powers of 5, or powers of 2, or powers of 12. That's what it is. Anyway, like I said, we can do some more examples in the collaboration meetings. Just come and ask questions, and I'll be there to help. And ask your group members to help. Go for it. All right, so now you can see that understanding place value is incredibly important because it's one of the things that allows us to operate on our numbers using our numeration system. One of the reasons we love our numeration system so much is because it makes operating on things so much easier. Try to do these operations with Roman numerals and you'll just groan and roll your eyes immediately. Nobody wants to do it. Um, oh yeah, this is also considered foundational understanding for elementary school students. If students do not have this type of foundational knowledge, it's going to carry with them for the rest of their mathematical career, all the way up through high school, all the way up through high school. You got to catch them early on. Oh yeah, so some other things, even the vocalization or the syntax of spoken language can cause issues. So you have to keep this in mind when you're working with your students. For example, the way that we say the number 18 in English is like this. We say 18. Now, this is a linguistic shift because it's basically saying 10 and then 8. So really, this is trying to say 10 and 8. Oops. Right? That's what it means to have 18 objects. You've got 10 objects, and then you've got 8 more objects. That's 18, right? But notice that it's kind of backward because we're saying 10 on this side and then 8 on this side. But we pronounce it as 8 on this side and 10 on this side. So it's like switched, right? Now compare that to how you say 18 in Spanish. You say 18, which means 10 and 8. So notice it's almost more aligned with the numeration system than English is. It almost jibes even better than English does. So keeping things like this in mind can really help because if this is how they speak it and this is how they write it, it can throw things off if we're trying to get them to read stuff like this and saying that it's the same as this. So just bear that type of stuff in mind. Read section 2.5 in the book if you want a more detailed explanation for these issues for learning about understanding place value. Okay, whew. All right, that's it. Like I said, this is a short lecture. I guess I hadn't said that yet, but I'm saying it now. This is a short lecture. Let's take a look at activity 2B, and then we will call it a day. Activity 2B, here we go. Operations in different bases. So now the first page is just doing some computations in different bases. So you should put your work here, and here, and here, and here, just some standard practice. And now this question is a really fun one. This is the Felix problem. Oops, sorry. This is the Felix problem. And you're going to read this, and then you have to answer a few questions about how many bushels, baskets, trucks, and loose apples Felix has. So it's a really good one. I won't tell you too much about it because it's fun to explore, I think, and we can talk about it at the collaboration meeting too. All right. So I think that's about it for this lecture. Yep, I guess that's it. All right. Have a good day, everyone, and I'll see you next time.